All right, so you're saying move everything to one side. So I'm going to subtract 64x from both sides?
Yes.
All right, I'm going to follow your lead here and see what happens. What do I need to write here? Greater than or equal? Greater than or equal to 0, right? I don't know what that was. Everyone agree?
Yes.
Okay. Factor out of 4x. Okay, hold on. I want to make sure everyone is paying attention. Hold on. Everybody? Agree with this? Because we're about to make a mistake, I think. All right? So I want everyone to be paying attention to when we make the mistake. Then what? No, I want you to keep going. Don't worry. Factor out of 4x.
X plus 4 times x minus 4.
Yeah, because
that'd be 4x.
That's right.
X plus 4 and then x minus 4.
So now you're also seeing this as a difference of squares. Okay? So 4x, x plus 4 times x minus 4 greater than or equal to 0. I totally agree with everything that's been done. All right? This is okay. It's the next part that is the dangerous part. Okay? Now, your instinct, hopefully, is just to do each one of those, right? So this is what your instinct would possibly be. You would, don't write this down, okay? You would say, okay, well that means 4x has to be greater than or equal to 0. That means x plus 4 has to be greater than or equal to 0. And that means x minus 4 has to be greater than or equal to 0. That's what you would hope it would be, right? Because that would be relatively easy to continue with. Let's see what happens here. If 4x is greater than or equal to 0, could I divide both sides by 4? Yes? 0 over 4 is still 0. So this would mean x is greater than or equal to 0. Agreed?
Yeah.
Yes? If I do this, I get x is greater than or equal to negative 4 by moving over the 4 to the other side, subtracting 4 on both sides. And this is saying that x is greater than or equal to 4, right? Okay. We're good? No. I mean, do you follow me? Okay, now let's draw a number line. Let's put these points here. All right? Let's do that. Now, according to this statement right here, our answers have to be 0 or bigger than 0, correct? Which would mean anything from here, including the point, so I'm putting a dot, all the way out forever and ever, right?
Yes.
This one says, though, that x must be greater than or equal to negative 4, which would mean everything from here. I'll do it above. How about it? So we don't write on the same. This says everything from negative 4 forever this way, right? And then the last one says what? Everything greater than 4. Which would, if this is 4, we're saying everything from here to the right, correct? All right. So what interval is our answer? I mean, like, could you pick a number over here? Does it look like we could pick a number over here?
No.
Doesn't look like, because it doesn't satisfy any of these, right? Could I pick a number right in here between negative 4 and 0? Well, it only satisfies, well, it satisfies one of them, right? Is that all I need, just to satisfy one of them? I have to satisfy all? So, I don't know, right? I mean, we're kind of guessing. Maybe we just need to satisfy one, maybe we need to satisfy all of them. Agreed? So, what in the heck's going on here? Well, let me back up, all right? Because this is still kind of like a head scratcher. The original problem was this. No. 64x, right? When we moved it over, we had this before we factored, right? Okay, what I want you to do now is act like this isn't here, all right? Act like that inequality is not here. And I want you to look at this left side as a function. If that is a function, what type of function is it? Is it a line, quadratic, polynomial, rational? What is it? It's a polynomial function. Could you graph that for me? How would you graph it? So how would we graph that? How do you graph a polynomial? It's the first thing you do. Make sure it's a polynomial, then degree so you can figure out the left and right thing. What would this one be doing? Remember, I'm hiding. The left side would be going down, the right side would be going up, in the middle we wouldn't know. Agreed?
Yeah.
And then we would have to factor it to find the x-intercepts. We'd use the multiplicities, right? We get the multiplicities and then figure out if we're touching or if we're crossing. And where would we actually touch the x-axis, or where would we have x-intercepts here?
-4, 0.
Right? That's what we'd have. And would we be touching or would we be crossing through at those? Crossing. Why?
Because,
All the multiplicities are 1 on all the factors, right? So I'm going to be crossing through on all of them, and I start out by going down on the left, cross through, back up, right? Like this. So now if I say, when is this function greater than 0, I'm only asking you to what? Look at where the graph is above the x-axis. Isn't that what that means? Right? So the real answer here is what? The stuff between -4 and 0. Do we include, sorry,
yes.
we do include, right? So it would be -4, bracket to 0, union 4 to infinity. That's the correct answer. This does not indicate that at all, does it? Like, I'm supposed to be between -4 and 0, right? Well, that says I should be there, right? But then what about the stuff between 0 and 4? This says what? That 2 of them are satisfied? So why wouldn't it be part of the answer? So what I'm getting at is this is a complete mistake to do it this way. It leads you to just complete chaos. This does not get you to the result. All right? So what we want to do is not this, if that makes sense. I hate showing students what not to do, but that's the biggest mistake that students make. They do it anyway. Even if I don't show it to them, they do it anyway. So this brings us into what today's topic is, and that's how do we solve what are called polynomial inequalities or rational inequalities. Yes. All right, so here we go. It is. All right, so polynomial and rational inequalities. If we are ever trying to find or solve any of these inequalities, so you have a polynomial function greater than 0, or you could have less than 0, or greater than or equal to 0, or less than or equal to 0. There's 4 possibilities, right? Then we're going to use the following method. What was our polynomial over here in this problem? What was our p of x? It was the 4x cubed minus 64x. That's the polynomial greater than or equal to 0 was the problem we were looking at, right? So let's look through this method to see what it says. First of all, we move all terms to one side of the inequality to get our polynomial, right? We had to move that over to get that to work. And then make sure you got a 0 on the other side. The next step is to sketch the polynomial. Well, we already know how to sketch polynomials. And then we determine the answer. So this is really, there's nothing new here except that at the end what we're going to do is figure out where the graph is either what? Above here. This would be what? Above the x-axis but not touching. Below the x-axis but not touching. Above the x-axis and touching. Below the x-axis and touching. Make sense? So it's the same. There's nothing new. So let's do the first one. I think we just did the second one. We did B already, but let's look at A. Solve x plus 4 squared times x minus 3 times x plus 8 strictly greater than 0. So what we want to do is first move everything to one side and get a 0 on the other side, which is done already. The next thing we want to do is sketch the polynomial that's on the left side. If it's a polynomial, we have to make sure this is a polynomial, right? So that is a polynomial. So this piece right here is p of x. I need to now sketch it. And to sketch polynomial, we need left and right behavior, don't we? So we need a degree and we need a leading coefficient. What is the degree of this polynomial?
2.
I heard 2, I heard 4. 4? I'm hearing 2 and 4. 4? This one right here acts like a what? Like an x squared, right? This one acts like an x, and this one acts like an x. So it's x squared, x, and x, which is x to the 4th. The leading coefficient would be what you get when you look at all the numbers in front of these x's right here, like this. What would the leading coefficient be? Positive, right? 1. So we know from investigating that polynomial, it's going to go, what, up on the left and up on the right? Isn't that that's what a degree for polynomial would do if the leading coefficient is positive, right? That's what would happen.
The leading coefficient is positive and negative, not odd and even.
It's positive, negative, not odd and even. I'm referring back to that table I made, right, where I had the different scenarios. All right. The next thing to do would be to set it equal to 0 and factor it out, which we already have, don't we?
Yeah.
So what are the x-intercepts for this thing? Negative 4, 3, and negative 8. Just setting each of these factors equal to 0. What else do we have to determine about these x-intercepts? Not just where they are, but if they touch or cross. So am I going to touch or cross at these? How about negative 4? Touch. T for touch. Is that all right? T for touch. And that's because the multiplicity is 2, right? So even power, it's going to touch there. How about for the 3? Cross it. And negative 8? Cross it. So here's my quick sketch. Here's negative 8. Here's negative 4. And here's positive 3 way over here. Those are my x-intercepts. I'm supposed to go up on the left and up on the right. Bless you. I'm supposed to go to negative 8 and cross through, right? And then when I get to negative 4, touch, come back down, and then back through and cross through, like that. That is the sketch of that polynomial function. Yes?
I just always get confused on when you know you're supposed to touch it.
If you, okay, you understand where these numbers come from, right? Then when you look at the negative 4, you say it came from this factor, right? You have to look at the power on the factor.
Oh, okay.
It's always the power to figure out the touching and crossing. If the power is even, you touch. If the power is odd, 1 is odd, then you're going to cross. So now we get back to the original problem. We want to know when this thing, right, is bigger than 0, but not equal to 0, right? Bigger than 0? Where is it bigger than 0? So over here in this region, right, we're above the x-axis over here, and then over here in this region. So I heard Lily, she said negative infinity to what? Negative 8, bracket or parenthesis? Parenthesis, because we want it strictly greater than 0, right? At negative 8, you're actually 0. I don't want to be 0, I want to be bigger than 0. So parenthesis, and then union, parenthesis, 3 to infinity. That would be the answer. That's the solution. Okay, so the original problem was this. Right? This is the original problem. And so what we're saying when we put this down here is what x values make this true? Your answer is any x value in here or in here. You give me any number in there or any number in there and you plug it into this, I guarantee you it's going to be a true statement. Let's pick one. How about, let's pick a number over here. 4? Okay, so we plug in 4, we get what? 8 squared. 64. 4 minus 3, 1, so 64 still. 4 plus 12, so 64 times 12, that's a positive number, right? It's bigger than 0? It works. But if we try a number that's not in here, it shouldn't work, like 0, right? We plug in 0. 0 here, we get 16. 0 here, negative 3. 0 here, 8. So you have like 16, negative 3, 8. You multiply those together, it's going to be a negative number. It won't work. Make sense? Okay, I want to do one more thing on this. What would happen to your answer if I had changed this to this type of inequality where you do include 0? Okay, brackets, everyone agree?
Yes.
This will become a bracket. One more thing.
It touches the 4.
That's right, it touches at negative 4, doesn't it? Isn't your function 0 right there? You have to include that. So how do we include that? We would say union, and then how do you say a single number? You don't use brackets. You use a set of braces. Negative 4. Why did I put a bracket? I changed the problem. I was asking everyone what would happen if I put an equal here underneath. If I put an equal, it would change the answer where you would have to include the two endpoints because your function is 0 at negative 8 and it is 0 at 3, but your function is also 0 at negative 4. And the way that we include a single point is to use a set of braces instead of a set of brackets. All right? We call this right here, we call this an interval. Because we're referring to everything inside of it, right? Everything inside of it. This right here, we call a singleton. A singleton.
Or just a number.
Singleton. I think that's the way you spell it, a singleton. It's just a single answer, right? A number. But the way you represent a singleton is with a set of braces. Okay. We already did the part B, right? So let's see about part C, or example C. X to the 4th is less than 3x squared minus 2x cubed. So when you're looking at this now, I'll put something over here. If I were to give you this problem right here, we would look at this equation and we would say, hey, that's a quadratic equation, right? It's an equation, it's a quadratic equation. We move everything over, we try factoring, we might use the quadratic formula to figure out the answers. There should be 2 answers, could be 1, could be none, just depends. The language though is quadratic equation. This is called a polynomial inequality. It's a polynomial and it's an inequality. And that's what we're studying here, polynomial inequalities. The other part of today is we're going to study rational inequalities, but we're not there yet. So those are the 2 topics today, polynomial and rational inequalities. All right, so this polynomial inequality, the first thing we'll do is move everything to one side, right? And get a 0 on one side. And which side do you want to go to? You move everything to the left? Okay, so if I do that, x to the 4th, then what?
Minus 3x.
Minus 3x squared? Plus. Yeah, do you want me to reorder it now? Okay, so plus 2x cubed minus 3x squared. less than 0. You can factor out an x squared. You'll be left with x squared plus 2x minus 3 less than 0. Can you factor that remaining trinomial? X plus 3, x minus 1 less than 0, right? But this is where we are not going to sit there and set each of those, right, equal to 0. We're not going to do that. We're going to sketch it, right? So we're going to just look at this as our polynomial function and draw a sketch. What's the left and right behavior? Up, up. And that's from this, right? The x to the 4th power. That's what told us it's up, up. I have x-intercepts where? -3, 0, and 1. What am I going to do at each of these? What am I going to do at -3? Am I going to cross or am I going to touch? Cross through there. At 0, what am I going to do? Touch, because it came from the squared factor. And then over here at this 1, I'm going to cross. See, what we want to get to is a point where we're not sitting here and, having to write down, x is 0, x is -3, x is 1, and then put touch, cross. That we're all kind of doing that mentally. We're kind of just looking at, oh, okay, yeah, I know that I'm going to answer at 0. I know it's going to touch here, right? Hopefully, yeah, hopefully. That comes with time, right? Time and practice. All right, my two sides are going up. At -3, I will cross through. At 0, I will touch, and then back through up to 1 and cross through. It'll look like that. And I'm interested in determining where this polynomial is below the x-axis. -3 to 0, 0 to 1. So why not just say -3 to 1? At 0, it is 0, and do I want it to ever be 0? No, I want it to be strictly less than 0. So I cannot include 0 in my answer. So it will be, the correct solution will be the interval -3 to 0, union 0 to 1. That's the answer. We okay with that? No questions? Okay, just for the sake of knowing, what would happen if I change that to an less than or equal? I would want to put, instead of a parenthesis, I would do what? Bracket, -3. And now I don't have to stop at 0, do I? Because it's okay that it touches. So I can include 0 and keep going. So just -3 to 1, and that's it. Brackets on both ends. See the difference between those two? Why are y'all looking at me like that? All right. The last one. Why don't you try this next one on your own? Let's see what you can do in about 8 minutes on part D. All right. Go. See what you can do. Help each other out. What if you had infinity?
Yeah, over here, but the graph is like the same, almost.
I'm not sure I understand what you're asking.
Y over here is infinity to negative.
Why is it?
Yeah.
Because that's where the graph is above the x-axis, right? You're looking at the x values. When you say where is the function positive or greater than 0, you want to know where it's above, right? And so what you're saying is these are question marks. What x values can you plug in that would spit out a positive number? So it's the x values that represent your answer, okay?
Okay, yeah, thank you.
It's kind of like a domain problem in the sense that our answer is going to be an interval. If you get the answer, raise your hand. I want to come by and take a look. Good. Good. I think for the most part, everyone realizes they're going to have to use the synthetic division to break that thing down. That's the only way it's going to factor. Did anybody get a number to work in synthetic division yet? Negative 1 works? I don't think negative 3 works.
For the first one, negative 3.
For the first what? Negative 3 won't work.
Oh, no, I see it.
Do you have a question? You got it? Okay, so you got the graph? Is that your graph right there?
Yes.
Okay. That looks... Okay, so it's between negative... And we wanted it below, yeah, or equal to. Yep, that looks good. I think your polynomial is going the wrong way. Your left-right behavior. It's down on the left, up on the right. Yeah, that looks good. I got so many synthetic divisions. Oh, you got it on the first one. Okay, that one worked. Oh, and you just kept going instead of, okay. 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 I'll give you another minute. Okay, I think that that's probably enough time. I've got the solution here on the board. So you moved everything over to one side. You can't factor that unless you use your rational zero test. So you set up your synthetic division, and -1 works. And so you bring down the opposite, x plus 1. The remaining polynomial is this. And that you could do synthetic division again, or if you know how to factor that, it's x plus 9 times x minus 4. And that gives you 3 x-intercepts, -1, -9, +4. We will cross at all of them because they're all to the first power. And my left and right hand behavior was over here from the x cubed, so it should look like this. The red region is the region below the x-axis, which is what we wanted. We include the points -9 and 4 because those touch the x-axis. We have equality in the original problem. So in red here, that's the answer. Anybody have a question about that? No? All right. All right, we're going to move on. Let's look at that. Let's compare that to this. So I'm going to start with a problem here. Let's see how you handle this. So what if we had something like this? Let me get the first example that we're going to do here. X plus 7 over x minus 4 greater than 0. Is this a polynomial inequality? I guess yes and no. Polynomials don't have a fraction like this, right? If you have a polynomial divided by a polynomial, we called that a rational function, didn't we? This is a rational inequality, though. So this is not a polynomial inequality. It's called a rational one. So this is the second type that we want to look at today. So any instinct here as to what to do?
Sketch it with all those steps.
You want to sketch it and just figure out where, in this case, where it would be above the x-axis?
Same way we did the other one, just follow the steps for the rational.
We know how bad it is to sketch this, though, don't we? Don't we know the trouble, like, of sketching one of these? They're kind of tedious. But that's what we could ultimately do, couldn't we? We could sketch that and figure out where it's above the x-axis. Or have a shorter method, where we don't have to sketch the whole thing. What are the things that would be really important to us? The x-intercepts, and probably the vertical asymptotes. Those would be the most important things to us, because if we have, let's say, an x-intercept here, let's say a vertical here, then it could be doing something like this, right? Or it could have maybe come through and touched and come back up. And then on the other side it might be the opposite. But the horizontal asymptotes really don't tell us much. All right? They don't really matter. So because of that, we're going to focus most of our attention on just the x-intercepts and the vertical asymptotes. That's the only thing we'll want to really address. But I do have a process for it, okay? And it's in the notes, and it's right here. Let's see if we can see why this is going to work. First, move all terms to one side of the inequality. So look at this problem right here. Have I moved all terms to one side of the inequality and got a 0 on the other side?
Yes.
Yes. Okay, so that's just to make it look like that first. This left side, right here, needs to be written in the form P of x over Q of x. So you have two polynomials in a ratio like this. All right. What did I put under there at the very end of step 1? This step may require getting a common denominator. In this problem, we don't need to do that. But in a future problem, we will have to possibly get a common denominator when we move everything to one side. You'll see. Step 2, find where the x-intercepts and vertical asymptotes occur. Omit any holes. So where would the x-intercepts occur here? How do you find x-intercepts? Set the top to 0. So x is -7. How about the vertical asymptote? Set the bottom to 0. X is 4. You understand what I'm doing here? Finding out where my x-intercepts occur, where my vertical asymptotes occur. Now look at step 3. Break up the number line into intervals using the points we just found. So what I'd like for us to do is actually draw a number line, and I'd like to place these points here. X-intercept of -7. Does my graph actually hit that point? Yes. X equals 4 is over here. Does my graph actually hit this point? No, it's a what? It's a barrier, right? So just remember, this is not part of your graph, right? I mean, your function cannot ever exist at 4. Right? That's the third step. Questions? Step 4. Pick random points within each interval and test it with the original inequality to determine the solution set. So you remember with rational functions we did test points? Same sort of thing, we're going to do test points, but just on this. We're not going to try and draw the whole picture. We just want to know where it's, for us, where it's above the x-axis, right? That's all we want to know. Where is it above? So what test points should I pick here? I'll leave this up here. -8? -6? 0? 0 is a nice one. Wait, hold on. I'm on the wrong side. Sorry. 5. How about 6? I could have picked 0 in here, but that's okay. You said -6. We'll go with that. So I'm going to test 3 points. And where am I going to test them? Where does it say to test them? The original inequality. Now, this is the original inequality, isn't it? Let's test -8 first. So I'm testing -8. Here it goes. -8 plus 7 is -1. I'll write it down. -8 plus 7 over -8 minus 4. I'm testing this right now. Is this bigger than 0? Question. Is this true? Yes? Because what do you get on top? -1. What do you get on the bottom? -12. Is that bigger than 0? Negative divided by negative is positive, isn't it? Negative divided by negative is positive. So this is a positive number. It's bigger than 0. All positive numbers are bigger than 0. So this works then? That works? That means that anything over here works, all right? Or if you want, you could you could say I've got a point that goes up here, like this, right? It's above the x-axis. What I would like you to see it as, though, I'm going to leave the point there, but what I'd like you to see here is that we really have like three regions. We have that region, and we have this region over here. And we're checking to see, does something work in this region, right? It worked. So this region, this whole region to the left of -7 is a go. That's good stuff over there. Then I'm going to check something here. That's going to tell me what's happening in this region. And then over here, it's checking and seeing if it works here, right? So how about -6? Does -6 work? It doesn't work? Okay, so let's see. I put -6 plus 7 over -6 minus 4. Is that greater than 0? Well, that's 1 over -10. Is that greater than 0? No, that is not greater than 0. Which tells me that anything between -7 and 4 does not work. And then finally, 6. You plug 6 in, does it work? 6 works. I won't do the work, but check it yourself. 6 works. So what's my answer then? So everything over here works, right? So negative infinity all the way to -7. And you're saying parenthesis, why? Because it was greater than, right? So we say this is strict inequality. So we do not want to include the -7 in our answer, right? And then union from 4, right? 4 with parenthesis off to infinity. So answer is negative infinity to -7, parenthesis union 4 to infinity. That's it right there. Are there any questions? It's a slightly different process than the other ones, right? But it saved us from having to draw the whole picture, which is good. Now pay close attention to this. How would my answer change if I change this to that? So I would include -7 this time, right?
Yes, but you still would not include it.
Thank you, Lily. You would not include 4. Why not?
Or because it's a asymptote.
Because 4 is a vertical asymptote. 4 can never be included in your answer because your function doesn't exist there, right? So even though it's asking for equality, -7 is a point on the graph. So you can have it as part of your answer. 4 you cannot. Yeah? So I'd still have a parenthesis on the 4. That's how it would change if it was the other type of inequality. These are little subtle things that you have to pay attention to. Let's look at C. Want to do C? Or we'll do B. We'll go B first. X plus 1 times x minus 4 all over x less than or equal to 0. That's a rational inequality. We've got to move everything to one side. We've got to make it look like P of x over Q of x. And it already does. So we don't need to do any work here. We've got this. Once I've got it looking the way I need it to look, what should be my next step? X-intercepts and vertical asymptotes. All right. How do I find the x-intercepts? Set numerator equal to 0. And what are my answers here? So my x-intercepts are going to be -1 and 4. How about my verticals? Just 0? Okay. Now I'm supposed to plot these on a number line. -1, 4. Those are points on my graph. And then at 0, I've got a vertical, don't I? Yep, so it's the same thing. Test points are going to come in between my x-intercepts and verticals, so I should have one more than the number of x-intercepts and verticals added together. So I should have how many test points? 4. And I'm actually going to come up with, it's going to create how many regions here? How many regions do we have there? We have 1, 2, 3, 4 regions possible for my answer. Test points, what do you want? -2? Ooh. -1/2 or -0.5? 2 and 5. I circle those because I want you to know those are test points, right? That's why I do that. Where am I testing these? To the original inequality. I'm checking to see if it's good or not, right? Does it work or does it not?
Why couldn't you do it with the factor form? Like say we had the factor, could you use the factor form? Then what's the issue with using that?
There's no issue.
You just seem like you're really stressing the original.
Yes.
Like, because eventually we'll have to move another fraction over or whatever, another rational.
Like look at D, right? You see D? When we go to do D, the first step we're going to have to do is move the 3 to the other side. And then we'll have to get a common denominator. It's going to be a mess. So when you test, go back to that. Because if you mess anything else up in the process, at least your test point's going to be going into the correct thing. I guess it's just to help you avoid mistakes. Okay, so -2 here is going to go into this. And can you all give me a thumbs up or thumbs down on that? -2. -2 goes in here, you get what? -1 times -2 right here, you get -6. And then on the bottom, -2 right here, you get -2. Is that less than or equal to 0? Yes. Because you have a positive on top, a negative on the bottom. That's going to give you negative. It's less than 0. So does that region work? Yes. This region over here works. Next one's not going to work? So they switch? So it's not going to work, it's going to work, it's not going to work. Now let's be real careful about the answer here. I'm not testing all those, it's going to take too much time. We'll trust Lily and Nathan. So let's see. Let's ask someone from a table that doesn't have their names on. How about that? Are you raising your hand? You're muted for this one. Just for this one. All right. I want someone else that doesn't have a name tag in front of them to tell me what the solution set is here. Go ahead.
All right, so I got parentheses, -infinity to -1.
Okay, hold on. Parenthesis, -infinity to -1. What do you want me to do with the -1? Bracket, because I want to include it, right? And it's part of my function, so I can include it. Then union.
0 with the parentheses.
0 with the parenthesis. To where?
To
4 with
the bracket.
a bracket. So why did you put a parenthesis on the 0 but not the 4?
Because it's a vertical asymptote.
Because it's a vertical asymptote. You can never plug 0 into the function, so you can't have 0 as part of your answers. See that? But we do want brackets on these because we do want it to be 0. If it's possible to be 0, then we want to include that in our answer. Any questions on that? All right, let's look at C. x minus 3 squared over x squared minus x minus 30 is bigger than 0. So do we have a polynomial, rational expression here all on one side greater than 0? Yes? So I have a p over a q. So that part of it I'm good with. P of x over q of x. In this case it's greater than 0, right? So I'm good with that. All right. You're supposed to find the verticals and the x-intercepts at this point, which means you're going to need to factor the bottom, right? So let me rewrite this factored. How does the bottom factor? X minus 6, x plus 5, greater than 0. What are my x-intercepts? Just 3, right? Okay, what about my verticals? Negative 5 and positive 6. How many test points am I going to have? I'm going to have 4 test points. So let's make sure we get these drawn out correctly here. 3 is an x-intercept. 6 is a vertical. And negative 5 is a vertical. I have created 4 regions to test, and now I plug in. Yes?
Does that, maybe this question been asked for, really, was the positive that shortcut thing that we did, positive and negative, we'll just plug it in?
Will it work?
Yes.
It will work if you're looking at this one right here, because you have multiplication on the bottom. It wouldn't work here because you have subtraction. And so you just have to be careful with it. Just make sure you're doing it correctly.
Okay, so, yeah, so in this instance, it would not work.
Not in that, but in this it would.
Or we're supposed to use the original inequality.
That's right, to be safe. I think the next problem will really illustrate what I'm saying. So let's test negative 6. If I plug negative 6 in, what can you tell me about the top? It's going to be positive because you're squaring it, right? So the top really doesn't matter. It's really just what happens to the bottom. So we get negative 6 squared is 36, right? 36 minus a negative 6 is plus 6. So 42 minus 30. It's going to be positive, right? So you have positive over positive. That's greater than 0. So yes, it's a good. I can include it. Okay. How about at negative 1, 0? I like 0. Whenever I can use 0, I like to use 0. Right. Oops, I'm sorry.
Points added or subtracted.
I'm turning it off. I have to answer it. If I answer it.
Count the time to check your text message after that.
But I told you, that's different. All right. All right, 0. What's happening? Positive on top. What about down here? This will be negative 30 on the bottom. So you have a positive over a negative, which is negative. Is a negative bigger than 0? No. So that does not work. And so Lily, it's just going to switch back and forth, right? Because that's the pattern? No, it's not in this case. It's not. Right? It's not going to switch. Try 4 and what happens? Plug 4 on top, doesn't matter, it's going to be positive, right? On the bottom though, 4 squared, 16 minus 4 is 12 minus 30, it's negative again. So you get positive over negative, it's negative. That's not going to work, it's not bigger than 0. So this one doesn't work, does it? And then if you try 7, it's going to work. So you have to be careful. Don't just get that first one and be like, oh, they always switch. Answer. Negative infinity, -5, parenthesis union, 6 to infinity. That's it. Is everybody catching on to this? Kind of get the idea? All right, now let's look at D, because D is a little different. X plus 2 over x minus 8 is greater than 3. It's weird, like when I put a problem like this on the test, people do like the strangest things with these problems. Like they just completely forget what they're supposed to do and they just, I don't know, it's crazy. Okay, so we have to get it to look like this. We have to have P of x over Q of x and then greater than 0. We have to have this in order to use this procedure. So I have a 3 over there. I can't have a 3, so I have to subtract 3 on both sides. But when I subtract 3 on both sides, I cannot combine it with the fraction that's over there, can I? Not yet. And it doesn't look like this yet, right? It doesn't look like a polynomial over a polynomial. So I have to get a common denominator. So I'm going to rewrite the left side as 3 over 1. And then what is the common denominator I'm going to use? X minus 8? Hold on. Let me get my marker. I'm going to introduce on the top and bottom here, I'm going to multiply x minus 8. There. X minus 8. There. Right? Y'all understand why I'm doing that, right? Yes. Okay, so I get x plus 2 over x minus 8 minus 3x minus 24 over x minus 8 is greater than 0. So I distributed the 3 through the parentheses there. And be very careful because you still have to subtract this. Right? You have to subtract that, so isn't that going to change the signs? Right? This negative is going to have to go here and here if I put these two together. So I have x plus 2 minus 3x plus 24. That's what happens when I put them together. Over x minus 8 greater than 0. And then collect your like terms. So I'm going to put this over here. Negative 2x. And then plus 26 over x minus 8 is greater than 0. Now, does that look like a P of x over Q of x? Greater than 0?